Hello, welcome. Now, have you observed the difference between a charger cable and a copper wire? Have you observed that the charger cable gets heated up so quickly, whereas a copper wire can conduct electricity easily without being heated up? Do you know why? Now, that's what I'm going to be showing you today in physics. It is called resistivity. Resistivity. Now, if you are preparing for JAM or SSC, please pay attention to this because this is very vital. Now, in simple terms, resistivity in physics simply means how strongly a material can resist the flow of electricity through it, or how difficult a material makes it for electricity to flow through it. So a copper wire conducts electricity easily without being heated up quickly because a copper wire has a very high conductivity and then a low resistivity. On the other hand, most of your charger cables, the conductivity is not as high as a copper wire and the resistivity is what? Higher. And that's what we are looking at today. Now look at this. I said resistivity is defined as the resistance per unit length, the resistance per unit length, per unit cross-sectional area of the material concerned. Okay? Now I say it is denoted by rho as a Greek letter and measured in ohm meter. So take note, the SI unit of resistivity is ohm meter. All right. Now I said the resistance of a conductor is directly proportional to the length. Please take note, directly proportional to the length, that's one of the conductor, and inversely proportional to the cross-sectional area of the conductor. So if we bring out both things we have there, we say the resistance of the conductor is directly proportional to the length. So I have arrow, that's resistance, directly proportional to length, okay? And inversely proportional to the cross-sectional area. So the same resistance is inversely we bring by what? 1 over A. 1 over, inversely means 1 over. Cross-sectional area, the same thing as area. So I call this equation 1 and I call this equation 2. Okay? Now, if I'm to combine both equations together, I have resistance inversely proportional to what? Length times 1 over A. That will give me length over A. Okay? So arrow proportional to length over A because A is inverse. Okay, now if I introduce my constant, it becomes arrow is equal to what? K L over A. Now, of course, where K is the constant, and that constant is called what? Resistivity, which is our what? Rho. Okay. So I can change this to be resistance equal to resistivity L over A. So that becomes the formula we use for calculating resistivity. All right. Now let's look at this question. What the question we want to solve here. Now it says a wire 40 cm long and diameter 0.60 millimeter has a resistance of 1.5 ohm. Now what is the resistivity of the material? Now we are told to take pi as 3.142. Take pi as 3.142. Now let's quickly solve this. All right, solution. Now first thing first, we bring out our parameters. Okay, we are solving your questions in physics for the SSC students. You bring out your what? Parameters. Now, what are we given? We are told a wire 40 cm long, that is the length. long means length. So my L is equal to 40 cm. But the SI unit of length is meter. Take note, when calculating, your answers should be in the appropriate SI unit. SI, that's your system international unit, okay? The SI unit for length is meter, not centimeter. So how do I convert centimeter to meter? I divide by 100. That gives me 0.4 meter. All right, and diameter 0.60 millimeter. Now the SI unit for diameter is meter, not millimeter. So that means I'm going to convert this 0.60 millimeter to meter. And how do I do that? I divide by 1000, because 1000 millimeter make 1 meter. So if I do that, I have what? 0.0006 meter. Okay, so 0.0006 meter. Now we are told has a resistance of 1.5 ohm. So my resistance arrow is what? 1.5 ohm. Now the question says, what is the resistivity? Rho is unknown. I don't know it. But I know the formula that arrow resistance is equal to resistivity L over area. Now, what is the area? Remember the area, we're talking about the cross-sectional area. Now, the cross-sectional area of a wire is what? Circular. The cross-sectional area is circular. Okay? Now, what is the area of a circle? Pi arrow square. So I can say A is equal to pi arrow square. Now, what is my pi? We are told to take pi as 3.142, all right? Now, radius, arrow square. We're not giving radius, but we're giving diameter. And we know that radius equals what? Diameter over what? 2. Beautiful. So 3.142 times what? Diameter, which is 0.0006 over 2 all squared. That's my area. So now, if I put this in the formula, I have that arrow. What is my arrow now? 1.5 is equal to rho times L. What is my L? 0.4 over area. What is my area? 3.142 times what? In bracket 0.0006 over 2 all squared. Okay, so I will do what now? Cross multiply. So 0.4 times rho will give me 0.4 rho equals 1.5 with times everything I have there. So that's 1.5 times 3.142 times what? In bracket 0.0006